Let us continue our previous lesson, which is finding a derivative of a function using the limit concept. So now we continue with some examples. So let us take this example. For example, we have f of x equal to 1 divided by x, so such that x is not 0. So now we would like to apply our rule to find the limit of this function. That means what we want is dy by dx. So this is what we want. So now we already know that dy by dx, that is by definition is limit f of x plus delta x minus f of x divided by delta x as delta x approaches 0. So again, so we follow the same way of thinking. What we need is, so we need the f of x plus delta x, and we already have f of x. So we'll write them again. F of x, that is equal to 1 over x, and x is not 0. And then f of x plus delta x, that would be 1. So we come here and we replace x by x plus delta x in this case. So then we would have here x plus delta x. Now we have everything. So dy by dx will be equal to limit f of x plus delta x. There is no need to write it again. Okay, so f of x plus delta x minus f of x divided by delta x. So this step is not needed actually, as delta x approaches 0. So now we can directly write what is f of x. So f of x is 1 divided by f of x plus delta x is 1 divided by x plus delta x minus, and here we have f of x, which is 1 over x. So then everything here is divided by delta x as delta x approaches 0. So now that will be equal to limit, so delta x approaches 0, and now we would have here a common factor. We will take just the multiplication of x and x plus delta x. So now we'll divide this by x plus delta x, which is x. We'll write it here, and then we divide this by this, which is x plus delta x minus. So whenever we have more than one term, it is very important to open parentheses or brackets. So then that will be x plus delta x. So this is what we have here for the numerator, and then the denominator we divide everything by delta x. So now let us do it here. So now dy by dx will be equal to limit as delta x approaches 0. So here we would have, so x would cancel out this x because it's negative. Be careful, this negative is multiplied also here so it's multiplied by delta x. That means here we would have negative delta x, then divided by, so, and then here we also have we have delta x. That means here we would have delta x times x plus delta x. So now delta x would cancel out is delta x. Then here we have negative 1 in the numerator, so that means limit as delta x approaches 0. So we have negative 1 divided by x times x plus delta x. So now we see whether we can substitute directly. So we check if it is defined value. I mean, if the limit is defined, then it is okay. So if you substitute this by 0, then we get limit negative 1 divided by x times x plus 0, which is x, as delta x approaches 0. So you see that this is now it is independent of delta x. So that means it is similar to the limit of a constant, because we don't have, sorry, we already substituted, that is not the story. So we already substituted this value. So now we have, the final answer would be -1 divided by x squared. So this will be -1 divided by x squared. So we can write it here or rewrite it here again. We say our derivative is equal to -1 divided by x squared. So this is the derivative of our function, which is 1 over x. So we can take another example here. So let us take another example. So for example, if we would like to find the derivative of this function f of x equal to e to the power x using the limit, so this is just the Euler number. So and now here again we want to find dy by dx. This is what we want to find. So dy by dx using the limit is equal to limit f of x, this is just our rule, plus delta x minus f of x, and then divided by delta x as delta x approaches 0. Again, we need to just replace f of x plus delta x, and then also we need to replace f of x. So then we just can find the limit. So now here, so what we would have, so f of x, we already know it. So f of x, that is e to the power x, and then f of x plus delta x. So now we replace here x by x plus delta x. So that means dy by dx will be equal to limit e to the power x plus delta x minus e to the power x divided by delta x as delta x approaches 0. Cool. So now you see that we can write it in this way. We say limit delta x approaches 0. Here this can be written as e to the power x times e to the power delta x. You know that from the rules of exponents. So and now here we have e to the power x. So everything here is divided by delta x. So now we can do the following. We can say, so limit as delta x approaches 0, then here we would have e to the power x, e, so we factor out e to the power x, then we have e to the power delta x minus 1, and then that will be divided by delta x. So now you see that this function e to the power x is independent of delta x. That means we can take it out of the limit. So now here it is treated as a constant. Then that will be limit as delta x approaches 0. So here we would have e to the power delta x minus 1 divided by delta x. And now we would like to find this limit. So one way of finding this limit is to use a Taylor expansion. So this will be equal to, I just write it down. You can search how to write this function in terms of polynomials or summation of polynomials. So then that would be 1 plus delta x plus delta x squared divided by factorial 2, and then plus delta x cubed divided by factorial 3 plus and so on. So and then here that means, so dy by dx will be equal to e to the power x times, then here we would have limit as delta x approaches 0. So now we replace e to the power delta x by this, so we will have 1 plus delta x plus delta x squared divided by factorial 2 plus and so on. And now we have minus 1. Here everything, I mean this is negative 1, we just write it here. So everything here is divided by delta x. So you see that this will be cancelled out with this one. And now we have here, so we have dy by dx. So that will be equal to e to the power x limit as delta x approaches 0. So here we would have, so now we can distribute. We can say that will be equal to, so we can distribute this. So here we have delta x divided by delta x plus delta x squared over factorial 2 divided by delta x, and then we continue. So, and now here note that that will be equal to e to the power x. So this is just 1 limit as delta x approaches 0. Then here we have 1 plus delta x, because the squared would go with delta x divided by factorial 2 plus some other terms here. Everything here depends on delta x. So this will be e to the power x. After substitution, so limit 1 is 1, then plus everything here will be 0. So, and also for those terms, if you want to check here, because I just cut it off, but everything here will be 0, and that will be equal to e to the power x. So that means the derivative of e to the power x will be equal to e to the power x using the limits. So thank you very much for watching this video. So if you are interested in watching more videos in the future, please make sure to subscribe to the channel.